Hello scholars, I hope you all are doing well today. For this lesson, we're going to build off our last lesson on transformations of functions, and we're going to discuss families of functions. So have your notes ready, because you're going to need to take a lot of them, but I don't think you'll think it's too bad. Let's get going. So just as numbers can be classified into sets based on certain characteristics, such as certain numbers are odd numbers or even numbers or prime numbers or composite numbers, functions can be classified into families of functions. So the parent function of a family of functions is the simplest function with the defining characteristic of the family. You can see here in this diagram, this is for the absolute value family, which we'll talk about later. The parent function is y equals the absolute value of x. So that's the parent function, but all these other functions are in the absolute value family. They are transformations of the parent function. Some of these functions have been shifted, and one of them has been stretched vertically. So just think of the parent function as the original function, and think of all the transformations of that function as the offspring of the function. Now I know that we need two parents in order to be born, but functions reproduce asexually. Just a joke. Now there's a general formula that we use to figure out these transformations of the parent function. It might look kind of familiar to you. So the formula is f of x equals a times f of x minus h, close those parentheses, plus k. There will always be parentheses around x minus h. You'll see some different variations of that as we move forward. But check this out. H represents a horizontal shift. So you got an example of a rule where it's f of x minus 5. H is 5, so the function is going to shift right 5 units. K represents a vertical shift. So f of x plus 3, k equals 3, so the function shifts up 3 units. So here you see this at the bottom, f of x plus 3 minus 7, the function is going to shift left 3 units and down 7 units. Now let's talk about a. So for vertical stretches, the absolute value of a, that's what those bars mean, absolute value. The absolute value has to be greater than 1 for the function to be stretched vertically. So here's an example, 2 times f of x. The function is being stretched vertically by a factor of 2. You're multiplying 2 to all of the y values of its points. So for a vertical compression, the absolute value of a has to be between 0 and 1. So for example, 1/2. Here we're multiplying 1/2 times f of x. A is 1/2, so we're multiplying all of the y values by 1/2, so it's going to compress. Lastly, when a is less than 1, we'll have a vertical reflection, meaning that it's going to reflect across the x-axis. So you see, for example, negative f of x. When it reflects across the x-axis, when it has a vertical reflection, the y values will become opposite. So this example, a is negative 1, so the function will reflect across the x-axis. Now let's discuss parent functions and families of functions. Now let's discuss families of functions and their parent functions. The first family that we'll meet is the linear function family. The parent function of the linear function family is defined by y equals x, and you can see a graph of that here. You'll also be familiar with the equation y equals mx plus b. That defines a linear function. You can also see the general equation that we'll use for the transformations of the parent function is f of x equals a times x minus h plus k. And in class, I'll show you how we can get from that formula to y equals mx plus b. They actually can define the same exact line. Let's move forward. So here we have the quadratic function family. The parent function is y equals x squared, and the general equation is f of x equals a times x minus h squared plus k. Now, I want you to see something very important about this graph. we call this point the vertex. Function of the quadratic family, the vertex is always at the origin. Point that we can keep an eye on, and it'll help us to identify the transformations of the parent function in the future. Let's move forward. Next, we have the pleasure of meeting the cubic function family. The parent function of the cubic function family is y equals x cubed, and its general equation is f of x equals a times x minus h cubed plus k. So the only difference with that general equation compared to the quadratic equation is that instead of x minus h being squared, it's being cubed, cubic. Now check out the parent function. It's kind of a squiggly line. So it also passes through the origin. The point right here is called the point of inflection. And for the parent function, the point of inflection is at the origin. And here you can see transformations of that parent function. All of them belong to the cubic family. Next, we get to meet the square root function family. The parent function is f of x equals the square root of x, and the general equation is f of x equals a times the square root of x minus h plus k. So here, instead of parentheses, we have a radical over x minus h. Now notice that it is not going over that plus k, just x minus h. Now for the square root parent function, we have an important point, and all we have to call it is the starting point. That's it. They're also, at the origin, 0, 0. And here you see some shifts and some stretches and compressions of the square root function. Here we have the absolute value function family. The parent function is y equals the absolute value of x, and the general equation is f of x equals a times the absolute value of x minus h plus k. Here we have the graph of the parent function, and as you can see, it has a very important point at the origin. And just like for the quadratic function, we also call this the vertex. Now you can see all these transformations of the absolute value function family. You see it being stretched and compressed here, and it's being reflected in this one. We have the constant function family. It actually is kind of weird. It doesn't really have a parent function. We would define it by the equation f of x equals c, where c is just any number. You can see right here, it says f of x equals c, but it's going through y equals 2. So c in this case actually equals 2. C can be any number. It's just a constant, just a number. And be careful not to get it confused with linear functions. Y equals c is different than y equals x, because c is a constant while x is a variable. Be sure to make note of that. Now let's try this. The first problem says to identify the family of the function. Well, we recognize this shape. It's actually a parabola. I don't think I mentioned that earlier. Quadratics are always in the shape of a parabola. So this belongs to the quadratic family. That the parent function of the quadratic family is f of x, or remember you can say y instead of f of x. F of x equals x squared, or you could say y equals x squared, either one. Now we want to find the equation that defines this function. Now remember I told you that the vertex of the parent function starts at the origin. Use the vertex to find how the quadratic function has been transformed. So let's see how far away this vertex is from the origin. Well, it's 1 unit to the right, and it's 1 unit up. So if we're going 1 unit to the right, that means h equals 1, and we're going up 1, so k must also be 1. So 1 unit to the right and 1 unit up. So now we can use that general form, f of x equals a times x minus h squared for the quadratic family, right? It's squared plus k. Now it actually has not been stretched vertically, so a is going to equal 1. If you multiply something by 1, it doesn't change, right? Like 1 times 2 is just 2. It has not been stretched or compressed, so A is just 1. So I'm going to substitute 1 for A. And if I substitute 1 for A, I actually don't have to write A. So then x minus 1, because h is 1, plus 1. So I hope that lesson helped, and I just want to encourage you to really study those families of functions, especially the parent functions. Make sure you're able to just look at a graph and be like, oh, that's an absolute value function, that's a quadratic function, etc. Because I think that will be really helpful for you moving forward. So come to class prepared with questions and ready to practice what you learn. Good work today. Thank you, Collegiate Scholars.